Hi, okay. You have made it to the end of the course. We are going to consolidate our learning and then that will be that. So everything that you're about to see is adapted from exam questions. So they're going to give you a really, really good feel as to what to expect from the real thing. We are going to work our way through. I really would like you, if you are stuck, to look at your notes. It's not a test. I want you to be able to go away and research it if you're not sure, rather than just watch me do it. Watching me do maths isn't as good as you doing maths, okay? So hit pause, have a go at the first question and press play when you're ready. Right, we've got to write this first one as an ordinary number. So I can see it's -1. So I'm going to move 1 that way to get 0.43. And then we've got to work out the value of 2.4 times 10 to the 4 times 9.6 times 10 to the 5. So numbers first. 2.4 times 9.6 is 23.04. Then 10 to the 4 times 10 to the 5 is going to give me 10 to the 9. Put that together. And you've got that, which isn't standard form. We need that decimal point there, 2.304. So this side has just got smaller by that movement of the decimal place. So we're going to make this side bigger to balance it. And that should be your final answer. Okay, so hopefully it has started well. There's your next question. So a couple, expand and simplify. Pause and press play when you're ready. Okay, so x times x is x squared, x times 3, so 6x. And remember to multiply, not add. 6 times 3 is 18. Oops. And then collect the middle. Final answer, x squared plus 9x plus 18. Okay, next one, m times m is m squared. Then I've got m times -3, so it's -3m plus 7m. And then remember, it's not 7 take 3, 7 times -3 is -21. Tidy up that middle, and I've got m squared. -3 plus 7 is going to take me to +4. And that would be my final answer for the second one. Okay, next question. Hit pause and press play when you're ready. Okay, so this is trig. I need to find a missing edge. So it's SOHCAHTOA. That's my opposite. That's my hypotenuse. That's the adjacent. Don't even really need to label that on. It's got no value on the edge. It's not going to help me. The O and the H are the two edges with information. O and H is here. So we are going to be using sine. So sine theta is O over H. My angle is 30. My opposite is X. My H is 16. Take the divide by 16, it lands as times. I want to get X on its own, remember. And then 16 times sine 30 gives me X equals 8. And that will be centimeters as my final answer. Nice that it came out with a whole number. Doesn't often happen. Okay, next question. So this question is a little bit harder, a little bit wordier. So what I want you to do is obviously hit that pause and think, what do I know? Yeah, what am I looking at? What do I know about that? How can I use it? Go through that motion and repeat it every time you're stuck, because there may be that you've added more to it. So there's more to look at. And then hit play when you're ready. Okay, so I've got the arc ABC is a quarter of a circle. So they're making it clear that I'm looking at a quarter of a circle. Now, what you might want to do is mock up what the full circle would have looked like. Yeah. That section there is the section in our question. Okay. And sometimes when we're stuck, doing something like this can help us, which is why I'm demonstrating it. Okay. We're being told the radius is 4.6. Well, we can see that now that we've drawn the full picture. It's really clear to see. They want us to find the area of the shaded segment. So what I've got here and what I'm going to need to do is I've got the sector, the quarter of a circle, and I've also can clearly see a triangle. If I find the area of this and take it away, the area of the triangle, that will leave me the shaded bit. So that ultimately is the maths that we have to do. Now, if you hadn't worked that out, or you can already see at this stage something went wrong, you can always pause. So you don't, it's like I've given you a hint, and then you can have another go, can't you? So you only you will know if you need to do that. So I'm at that stage. I've digested what needs to be done. So the first thing I'm going to do is find the area of the quarter circle. Okay. So area of a full circle is pi r squared. I only want a quarter of it, so I'm going to divide that by 4. Okay. So pi times the radius is 4.6, and I'm going to divide that by 4. That's going to give me a result of 16.619, and on it goes. Okay. Now the area of my triangle, which is base times height divided by 2. Well, my base and my height is actually the same thing. So I'm going to be doing 4.6 times 4.6, and that's going to get divided by 2, which is going to give me a result of 10.58. So that's what I'm going to be doing. I'm going to be doing the 16.6190, take away the 10.58, and that is going to give me my segment that they wanted me to find. So 6.039, on and on it goes. Go back, always go back. What do they want the answer as? 3 significant figures. So I would go 1, 2, 3, cut. The 9 is going to create an add on the 3, 6.04. Now it's area, so it's centimeters squared, and that would be my final answer. So there's a lot going on in that question. There's a lot going on in a lot of these questions because they're obviously really at the higher end, aren't they? Okay, so next one. There you go. Press play when you're ready. Okay, another nice little crab's claw for us. Just be careful with those negatives. So x times x is x squared. Then I've got minus 4x, minus 5x, and then minus 4 times minus 5 is going to be positive 20. The 2 negatives make a positive. Collect up your middle, and you've got x squared minus 9x plus 20. Here we've got to factorize. Now, 2 terms, 1 bracket. This is F for factorizing. Okay, the common elements are the 3 times table and the x. So 3x is going on the outside. Now 3's into 6 go 2. I want x squared. I've got one of the x's on the outside, So the other X will go on the inside. And then I'm going to do 3s into 9, which are 3. I want just one X. It's already on the outside, so nothing else to do but close the bracket. So hopefully that's gone well. Next question. A number, well, I won't read it out. You read it to yourself and then hit play when you're ready. Okay, so 1 decimal place is giving me a 1 decimal place number line. So I've got my 18.2, 18.3, 18.1. I want my halfway points. So it's going to be 18.15. X is greater than or equal to that, and then it is less than 18.25. Quite often on the exam, they do all of that for you, and you just have to park the numbers onto the dotted lines. So if you ever do get a little bit muddled, then do remember that. The other thing is you'll notice I've used an X, okay, which is a bad habit sometimes we get into, and not use the letter that they've given in the question. So it's important to try and do what you're supposed to do. So really that should be an N. If you did put the wrong letter in by accident, so if that happened to you, they won't take away a mark, all right? So it doesn't matter if a slight difference is made there, because it's the numbers that are really important in this question. But that said, always check. As soon as you've checked, you'll see it, and then you can change it and replace it, can't you? Okay, there's your next question. So read through it carefully and then play when you're ready. Okay, now you will be given the formula. So I do hope you looked it up and didn't guess. If you didn't and you want to just take the formula now, okay, so the curved surface is, oops, can't write it in a light, is pi RL, okay, and you will be given that. So if you want to hit pause and have a go now, please do, otherwise I'll just keep going. So what we're doing is we're obviously covering the inside of the cone. So it's still the surface of that curved area. It's nothing to do with the circle, okay? So pi r squared is going to mean we do pi times the radius. Now, we've been given the distance all the way across. We only want halfway. So we must remember to spot for that. And then the L, the slant side, we've been given, which is awesome. We don't have loads of work to do. So that's times by 15. 4 times 15 is 60. So we've got 60 pi. That is in terms of pi. I'm only stopping there because it's not just about one cone. It's about covering 12 cones. So I'm just going to times that through by 12 and not worry about the decimal display until I've done that. That then gives me 2261.946, on and on it goes, okay? So that's the total surface area for all 12 cones. Going back and reading the question, I'm told that each chunk of chocolate covers 6 centimeters squared. How many chocolate chunks will I need? So this is the total surface area of the cones, which I now need to divide through by 6 in order to work out how many chunks I'm going to need. So when I do that, I get 376.99, and on and on it goes. The question is clearly saying 3 sig fig, so we're going to go 1, 2, 3, cut. The 9 will take that 6 to 7, so it's 377 chunks if I'm going to put my units in. Okay, so that is the answer to that one. there's your next question. So pause and press play when you're ready. Okay, so I have the keyword regular, and it's a pentagon, which I know has 5 sides. So really, honestly, I always do this, even before I've carried on reading. I've just gone, oh, it's regular. So straight away, I'm triggered into doing my triangle. It's a 5-sided shape. I'm just going to go straight on in and do some of the numbers. I know that the exterior of a pentagon is 72. So away somewhere, I'm going to write on 72. That therefore needs to be 108. 180 take away 72 is 108. Remember to always show you're working out. So I now know the interior of every single one of these is 108. Work out the size of SOT. SOT is this angle here. So I've got to now get across my diagram to O so that I get an actual answer. Now, this is really straightforward, not as hard as it looks, because I have got this interior and then I've got an exterior or an angle on a straight line, making that 180. So I now know that that is 72 there and 72 there. Because the angle's on a straight line, more than anything else, this is isosceles. It has to be because 2 angles are the same. Not that it overly matters, but that's what I've got. So 180, take away 72 plus 72, which is 144, gives me 36. 36 degrees is the size of that angle. And if you got that right, well done. Good work. Okay, there's your next one. Pause and hit play when you're ready. Okay, so this is another trig. So we're going to write down SOHCAHTOA and do our labels. That should be the first thing we always do. The X is here, which is opposite the angle we've been given. This is my hypotenuse. Don't really need that one as there's nothing on there, and that is my adjacent. So I can see this is important because it's got the X. This is important because it's got a number. It's O and A. So it's going to be tan. So tan theta is opposite over adjacent. Tan, I've got the angle of 34 equals opposite is X. A is 168. So if I want to know what X is, I get it on its own. So that 168 is going to land as a time. So I've got 168 times tan 34. I put that in and I get 113.317, on and on it goes. Check for my question. It says 1 decimal place. So 113.3 millimeters is my final answer. Okay, there's your next one. Hit pause and press play when you're ready. Okay, so I'm looking at a quadratic. I can see that because of the power 2. They want me to solve it. It equals 0, so it's all set up, ready to go. What it won't do is tell me I have to factorize, and that is something that I need to be able to sort of see when I look at this. It's got the power 2, it's got 3 terms. They are all indicators of factorizing into 2 brackets. So we've got X being dropped. I've got pos neg, so I've got pos neg. And I've got 35. So that's 7 times 5. Now I want to make a positive 2. So 7 is going in there and 5 is going to go in there. 7 take 5 is 2. Now I'm solving, remember. So these brackets need to equal 0. So X is equal to -7 and X is equal to 5. So same digit, opposite sign. Okay, hopefully that went well. And that is your next question. So another wordy one. I want you to take your time and just, yeah, pick it apart, have a go. Remember, what am I looking at? What do I know? How can I use it? And press play when you're ready. Okay, so I've got a track that has two straight sides of 30 and each end of the track is a semicircle of radius 21. Lee's running stride. So a running stride is obviously the distance between one foot and the other as you're running, and he's going to go round the track just the once, and we need to calculate how many strides. So the fact that he's going around the track tells me that this is a perimeter question. I need to know the distance all the way around. So from start to finish. So straight off, I can obviously see that the end points are semicircles. You know, if I was to put those together, I would have a full circle. So the full circle, I put that through, that's kind of like a split. You've got one at each end, haven't you? But the circumference there is going to be needed. So circumference is pi d. Now, remember, they've only given us the radius. So we need, they've given us the radius is 21, which means the diameter is double that, 42. So we've got to do pi times 42. That is going to get me that and that section of my running track. If I want to go all the way around the outside, I've got to add on 30 and add on 30. So I'm going to be doing pi times 42 plus 30 plus 30. I'm just showing it all in one go. There's a good chance that you would have put done it in sections and it's fine. So that's what I've got. On and on it goes. Remember, this is in meters. And this is something to be really mindful of whenever you're looking at this type of thing. We got meters and then we got millimeters. We got something completely different going on here. So I've got a choice. I either change my meters to millimeters or my millimeters to meters. Again, it doesn't really matter which way you choose to do it. I'm actually going to change my stride. So I've got 890 millimeters. If I divide that by 10, that'll give me 89 centimeters. I then need to divide that by 100 to get centimeters into meters, which is going to give me 0.89. So I'm going to take the total distance, 191.946. It's on my calculator display, just waiting to be used. I'm going to divide it by 0.89, which is going to give me 215.67, and on it goes. Okay, we're being asked to calculate how many full strides. He does 215 full and then a bit of one. So he's going to do 215. He doesn't do 216, so we can't round to 216. So 215 strides is the answer to that one. So hopefully that went well. And remember, it's not right or wrong, because if you can tick bits along the way, you know you've got methods. So if you didn't get 215, think about the bits that went well, okay? They will be giving you marks. All right, there's your next one. Hit pause, press play when you're ready. Okay, so we've got a regular pentagon. So straight in with this again. I've got 360 divided by 5, which is 72. Okay, I'm going to just mark it on. That's the exterior, which means I've got my 108 on the inside, showing everything all the time, so they can't catch me out. Okay, now they want me to work out the angle FBC. So we've got F to B to C. So that's that angle there. So now I've got to take a good look at this diagram because I need to work out what it is I know and how I can use it, okay? I've been told that I've got rectangles. So I know that obviously all these angles here are in the rectangle. So I know, and I'm going to do it in a different color, that there is 90 degrees, okay? I also know that, where are we? Get my color back, there it is. I also know that there is 108, okay? That in itself isn't actually going to be able to help me, because actually what I need to know is what that bit there is. Then that might be a bit more useful, okay? Because I know all of that's 90 and all of that is 108, but these two don't overlap. So whilst that might be a pathway of thinking, it will hit a dead end, as I've obviously demonstrated. So what we need to do is get this one. This is the bit that's important, just that section there, which is easily done because we've got an isosceles triangle. So we're going to do 180, take away 108, okay, which is going to give us the 72 again. So we'll write that down. We're going to divide that by 2 because we want to share it between these two, and it's going to be 36. So we've got 36 and 36. Okay. Now this is becoming more useful, okay, because I can take the 90, okay, if I've got my 36, I can take my, it's hard for me to show you. Let me see if I can do it here. I'm worried that I'm not making it very clear. That's why I'm a bit, What I'm going to be doing, okay, is I'm going to be looking at this section here, okay, and taking off the 36, okay. So let's do that first of all. I've got 108. I'm going to take off the 36, which is going to give me 72, okay. So I've done 108, and I've taken off the 36. So this blue section here, which I'm actually going to change to a completely different color now, that section there is 72. Okay. Now I can do the full 90, take away that 72 to leave me that bit there. Okay. So 90, take away 72 gives me 18 degrees. That is the missing bit. So all of this is incredibly important, but one bit on its own doesn't solve it, okay? Hopefully that was clear. You can at any point rewind and rewatch that if you need to. If you've got the 18 and you did it a slightly different way, there is nothing wrong with that. As long as you're working out makes sense and justifies the answer, you would get 4 marks anyway. But you shouldn't be massively off of what I've done because we are really working with the same numbers within the same diagram. Okay. Okay, that was a big one. There's your next question. So hit pause and press play when you're ready. Okay, so the first question we need to write in standard form. So it's really just a case of counting in and trying to, get that in the right position. Okay, so we've got, actually it's quite nice the way they've written it because we can go 3, 6, 7, 8. So we can say it's 2.4 times 10, and we went in 8 places. Okay, we've then got to do our division. Remember what I said before, don't put the whole thing in the calculator and just write an answer. We're going to do the numbers first. 1.87 divided by 9.21. That is equal to 0.203, and I might just do a little bit more, on and on it goes. We've then got 10 to the negative 6 divided by 10 to the negative 2. Remember that the take creates that positive, so minus 6 plus 2 is going to give me 10 to the minus 4. Okay. So what we've got at this stage is something that looks like this. Times 10 to the minus 4. Now that's not correct significant figures. However, we're not writing it in standard form. Sorry, it's not correct in standard form. And we don't really need to worry too much about that because we are just trying to write an ordinary number anyway. So the decimal point is here. Minus 4 is move it 4 places, 2, 3, 4, to make an even smaller number and rewrite it clearly. I've got 1, 2, 3, 4, then the 2, 0, 3, 0, 4, and it wants 3 sig fig, so we'll be cutting it there. There's your final answer. Okay, so really just keep checking in, making sure that you're doing what they're asking you to do, because it can be so tempting where you're working so hard in standard form to literally leave it that way. And we obviously don't want to for that particular question. Okay, next one. Pause and press play when you're ready. All right, so it's just a crab's claw that we need to be careful of. We've got numbers here on both of our x's, which will cause, more maths to happen. So we've got 2x times, no, let's not go to that one first. Let's go to that one first. So we've got 2x times 5x, which is 10x squared. And then 2 times minus 3 is minus 6. And 2 times 5 is plus 10x. 2 times minus 3 is minus 6. Tidy up that middle. You've got 10x squared. Minus 6 plus 10 is going to get us to plus 4. And that would be our final answer. Okay. There's the next question. So hit pause, press play when you're ready. Okay, so we're going to be putting a ribbon around a cake. So this is a circumference question, okay? And we want to find the least length that she needs to use. So the cake has a diameter of 24. Circumference, which is going to help us find that perimeter, is pi d. And we've got the diameter. So this is straight into the calculator, 24 times pi, which is 75.398, and on it goes. Okay, what is the least length she could use? Now, this is open to a little bit of interpretation, isn't it? Because you might be thinking about, in the reality of it and cutting it, what would you round to? Would you round to the nearest whole? It's got to be more than 75, otherwise it's not, there's going to be a tiny little gap. When they're not giving you something specific to round to, and it's just saying what is the least length that she could use, then you can interpret this. The best way, and is an appropriate degree of accuracy, is another way of describing this, is you can look at the number that they've given you. So we've been given an integer, and then you go 1 place value over, which is 1 decimal place. So 75.4. And also in reality, you couldn't cut anything smaller than a millimeter because our tools, our scissors, couldn't cope with being any more accurate than 2.1 decimal of a centimeter. So that would be the correct result for your final answer there. Okay. Right, there's your next question. Hit pause and press play when you're ready. Okay, so we have another trig question. So as soon as you've identified its trig, you write and do your labels. So my x, I look at first and go to the opposite. Then I do my hypotenuse. Then I do my adjacent and I see what I've got. I've got a number with the adjacent and a number with the hypotenuse. So it's cos. So it's cos theta equals A over H. Cos, the angle is X, A is 5, H is 14. If I want to know what X is, get it on its own. So cos is going across, landing as -1. And that is what you would put into your calculator, getting you 69.07, on and on it goes. We've been told 1 decimal place, so 69.1, and it's degrees because we were finding the angle. Okay. Now, I'm going to do this video in one. You may prefer to do it in stages. So if you are reaching a point where you're getting tired and you want to take a break, then please, please do. You don't have to do this all in one go. I'm going to keep going, obviously. You do what's right for you. Okay, so that's the next question. Read it through and then hit play when you're ready. Okay, here we go. So straight away, I'm reading regular. And it's also telling me something about the number of sides it's got. So as soon as I read it, I write my triangle. And I can see 360 divided by 15. That's how many sides there are. That is going to get me the exterior angle, okay? So I'm going to just extend and write on the fact that that is supposed to be 24 degrees. Remember, the diagrams are not drawn accurately because they don't want you picking up protractors and measuring. They want you to calculate and work out, okay? So if that is 24, I can also work out the inside really, really easily because it's on a straight line. So 180 take away 24 is 156. And if I'm honest, I haven't read the rest of the question yet. I get so into the fact that I've written that word regular that I just do whatever I can with it before I read the rest of the question, okay? Because nothing I've done can possibly be wrong. It might not answer the question, it might not help answer the question, but it's not wrong. So it says work out the size of angle BCA. So let's have a look at that. There's BCA. So they actually want me to find this angle here. Well, I can see it's enclosed into a triangle because my regular polygon is regular. It means all the edges are the same. So I'm looking at an isosceles triangle, but actually all I need to do now is do 180, take away the 156, which brings me back to 24. But this time that needs to be shared because I've got obviously the two angles of the isosceles. So this here and this here, that's got to be shared between. So the angle that I want is 12 degrees. Okay, so hopefully that went well. Next question. Pause and hit play when you're ready. Okay. So again, just another crab's claw. Really, really common, expanding and factorizing. That's why there's so much of it. So we've got 3x squared plus 6x plus an x plus 2. So when that gets tidied in the middle, we've got 3x squared plus 7x plus 2. So hopefully that went well. We've got two terms, which means we can use our F for factorising. We've got 8x squared plus 16xy. So we need to look at what's common, don't we? Well, the 2 times table, the 4 times table, or the 8 times table. Now we must, if we're going to get full marks, use the biggest times table. So that's going to be 8. X is also common in both. So the 8 and the X is coming outside of my bracket. 8s into 8s go once. I don't want to put anything here. It's going to change the fact that I've already got the 8 that I need. I've got 1x, I want x squared. So we need another x in there. And then I do the next one. 8 into 16 go 2. And it's positive. So I've got plus 2. I want an x, just one, which is already on the outside. So I don't want to be putting another one here. But I also want a y, which I don't have. So I'll include that and then I close the bracket. And that is the answer to that one. Okay, next question. Another wordy question for us. So I want you to just hit that pause, take your time, think about what you know and how you can use it, give it a good go, and come back to me when you're ready. Okay, so this is a bit similar to the other one that was a quarter of a circle, where they want just part of a shaded region. And this one is coming from the fact that we've got a rectangle. Oops, gone into straight edges, which is not making it easy. I've got a rectangle. When I take away the semicircle, it's gonna leave me that shaded region. So I've got to find the area of this, take it away from the area of this to get the answer that they want. So the area of the rectangle is, as always, pretty straightforward. So the area of my rectangle is going to be 10 times 6, which is 60. The area of my semicircle has to come from areas of a circle. Area of a circle is pi r squared. But then I don't want the whole thing. I only want half of it. So I will divide that by 2. So this is going to give me pi times the radius. Now, just remember the full circle with the semicircle with a 10 there. You can see that's a diameter. Oh, you can't see it because I did it under me. Let me do it here. There we go. That's what we're looking at. So you can see that that is a diameter. I only want the radius. So we've got to remember to recognize that, half it when it's necessary. And then that is the piece of maths that I need to be doing. Okay. That is going to equal 39.269. On it goes. So I've got 60, take away 39.269, on and on it goes. That gives me an answer of 20.7300. Look at what they want. They want 3 significant figures. So 1, 2, 3, cut. 20.7. The 3 is not big enough to have an impact, and it's centimeters squared. And that is our final answer. So hopefully that went quite well, especially after having had something, quite similar earlier that we had a go at. All right, so a little standard form for you. Hit pause and press play when you're ready. Okay, these are generally 1 markers. They can come on calculators or non-calculators. They're really just testing to see if you understand standard form. So we need to get that decimal point in the right place. It's going to take 3 movements. So it's 6.52 times 10 to the -3. This one is going to require a movement of 3 to make a bigger number. 1, 2, 3. It literally comes in off the end. There's no zeros or anything to add to this. That is the answer. Well done if you got that right. There's your next one. Hit pause and press play when you're ready. Okay, so I can see its trig. Now, one of the things that's interesting with this one is, as I said at the beginning, we are using questions that have been in exam papers. They've just been adapted slightly, so they're not the exact same question. And if you think about some of the earlier trig questions we did, where it literally just said work out X, this one has loads more information attached to it. It's much busier, but it's no different. And sometimes when there's lots of writing, it can be quite off-putting. All this is doing is talking through what you're looking at, okay? So don't let that put you off. So it's trig, it's SOHCAHTOA. There's my opposite, my hypotenuse. Adjacents here, don't really need to worry about that because there's nothing on it. It's going to be O and H, so it's going to be our sine. So sine theta is opposite over hypotenuse. Sine X is our angle. O is our 6.4 and 9.2. If I want to know what X equals, I get it on its own. So X equals sine lands as its opposite, which is -1, 6.4 divided by 9.2. In the calculator it goes, and you get 44.079. On and on it goes. It says 1 decimal place, so 44.1 degrees is the answer. Okay, we're doing great. We only have a handful left to go. There is the next question. So hit pause and press play when you're ready. Okay, so it's a regular pentagon again. So you can see how common this particular shape gets used in exam questions. Going to go straight in and do my 360 divided by 5 is 72. You're going to see, I just pop it somewhere away from the X at the moment, just so I've got the information in the diagram, okay, without it kind of getting too near where I need to know things, okay? So I know that about the regular pentagon. I've also got a parallelogram, and I've got to work out the angle marked X. Now, what do I know about parallelograms? So this key information, knowledge, needs to come and help solve this problem with us, okay? Now, the opposite angles of parallelograms are equal. So I do know that that is 107. I also know that it's a parallelogram is a quadrilateral, so the angles will add up to 360. So 360, if I take away the 107 and the 107, so that's 214, it's going to give me 146. And then remember, opposite angles are equal. So I only have to divide this by 2, and I've shared out the rest of the degrees. So 146 divided by 2 is 73. So I now know that that bit there is 73. And I've got everything I need now to solve it, because I know that this whole angle here is the inside of the pentagon, which is 108. So 108, take away the 73, and I've got 35 degrees. And that is what X equals, okay? So they will bring in other properties to complement, if you like, what's going on in the question. It's a way of them being able to write different questions that you may not have seen before. Okay, next one. Bit of expanding and simplifying. Off you go and press play when you're ready. Okay, so we have got x times x is x squared minus 6x plus 5x minus 30, tidies up. Minus 6 plus 5 is going to take me to minus x minus 30. And here we've got two terms, which we would normally say goes into one bracket. If we were to try and do that, so we've got x squared minus 16. Remember, I have to write something under here. What's common? X isn't common, and there isn't a common times table because this doesn't even have a number. It just has 1 in front of it. So this is impossible. And actually, that can be a really good way of making you realize, this is the exception to the rule, because if it's not going to work that way, it's got to be the exception of the rule. So down go our two brackets, drop our x, square root the 16, which is 4, and it's plus and minus. And that is that factorized. So if you got that right, if you remembered that, that's great. Well done. Next question, we are going to be writing these in order of size, starting with the smallest. So hit pause and press play when you're ready. Okay, so we need to put these into ordinary numbers so that we can compare them properly. Okay, so this is going to move 2 places to give us 350. This is obviously already an ordinary number, so we don't need to worry about the second one. The next one is moving 2 that way. So I've got 0.035 here. And then again, the last one is already an ordinary, but it does mean that I can see what's the smallest. So this is definitely smaller. So 0.0035. This is the next smallest. I'm going to write it using the number they gave me. Okay, then I've got 350, which is 3.5 times 10 to the 2, with that being the last one on the end. Okay. You will get 1 mark for converting, and then you get your other mark for putting them in the right order. So it's really important that you are not skipping this. Even if you think you can see it and you don't need to, you must write it down. All right. Okay, that's your next question. It's a long session. I hope you haven't done it in one go. Okay, so we've got a lot happening here, actually. We're being asked to work out the size of angle BCD, okay, which is here. Now, I can see the right-angled triangles. There's 2 of them embedded into this diagram. So straight away, it tells me that it's trig. I have to have 2 pieces of information to find the third. So to find this, I have to have 2 pieces of information on my triangle, which I don't have. I just have 1 here. So what I really need to do is to find this one. I can find this one using this triangle to help me. And then once I've got it, I'm good to go. So it's a double trig question. And I've got a double right-angled triangle diagram to help me do it. So I'm going to write my SOHCAHTOA as always. This is opposite my 67, and this is my hypotenuse. So it's going to be the sine. So sine theta is O over H, which is going to be sine 67 O over 13. If I want to know what the opposite is, I've got to get it on its own. So 13 is going to land as a times. Put that into my calculator and I get 11.9665, on and on it goes. Okay, so this value here is this edge here. So I'm going to be using that edge to help me with the next. All right, so I've got opposite again, so I haven't got to relabel that. That's really handy. And then I've got my H over here and my A. So for this question, it is O and A. So it's going to be tan this time. So we've got tan theta equals opposite over adjacent. Tan X, the opposite is my 11.966, and on it goes, divided by my 22. Now, that 11.9665 is still sitting on my calculator display, so I don't need to re-enter it or anything like that. I'm just going to have it there ready to use, okay? So if I want to know what X is, I've got to get it on its own. So X is going to be tan minus 1, 11.9665 divided by 22. Now, if you want to use it with it being already on your display, you'll do divide by 22 first, and then you'll do your tan minus 1 and put that answer in. Either way, you will eventually get 28.543 coming out. It wants it to 1 decimal place, which is very common with angles. So it's 28.5 degrees. If you got that right, really, really well done, because look at how much work there is there. And it's very easy to make a mistake on something like this. So well done if you got it right. Okay, there's your next question. Hit pause and press play when you're ready. Okay, so we've got an irregular octagon inside a regular octagon. So we've got two different things happening here. So we've got the regular octagon, which means that I can at least get started with finding some numbers. So I've got 360 exterior sides, 360 divided by 8 is 45. So I know on the regular, which is my larger outside shape, the exterior is 45. So the interior would be 135. I'll just put the maths together as well so that we've got everything for the examiner. So I've kind of done that. And then I've got to start thinking about the irregular octagon as well. Now, irregular means that the angles are going to be different size. The shapes share a vertical line of symmetry, okay? Now, vertical is straight up, okay? So that is saying to me that straight through the middle here is a line of symmetry. I can also see that these edges are equal. So it's actually telling me that all of these angles here have to be the same. They all have to be 168 due to the symmetry and due to these edges being the same size. So I have deduced that much so far. And I'm going to mark everything on. Now, I know that the inside angle of a regular is 135, and there are 8 angles all equaling 135. So if I do 8 times 135, that gives me the total of all the angles, and that's true of any octagon. If you think about your quadrilaterals, kites, squares, trapeziums, it doesn't matter what shape they take, they all equal 360. And 8-sided shapes are exactly the same. It doesn't matter what they look like. If they've got 8 sides, they've got 8 angles, and they will add up to one total, which is 1080. So I can take that knowledge and do my 4 times 168 and take that off. Okay, now 4 times 168 is 672. So 1080 take 672 is 408. So 408 has to be shared between these. So I'm going to divide that by 4, which is going to give me 102. So I've now got lots of information. In fact, I know every angle pretty much on that shape. I've got to work out the angle marked X, which is down here in the corner, okay? So I know that this blue angle here is 102. I know that the red angle is 135 because that's my regular octagon. So my regular octagon with 135, take away my 102, will leave me 33, and that's what X equals. All right. So hopefully you did okay. I think that one's quite hard because you have to be quite confident with these edges creating angles that are equal and so on. Okay. Right, there is your next question. All right, second to last. So we're nearly there. Hit pause and press play when you're ready. Okay, so we've got custard going inside tins, and we can see the size of the tins that's been given to us. He's going to be filling 100, and we've got to work out how much custard he needs to make and give our answers in litres. Now, they've given us the conversion, so we want to stay in centimetres to start off with. So custard is going inside. It's a volume question. So the volume is the area of the front face times the third length. The front face is pi r squared. So we're doing pi times the radius. Diameter is 6, so it's going to be 3 squared. It's got a height of 12. I put that in, and I get 339.29. Now remember, that's one tin only. We're actually going to be filling 100 of these tins. So I'm going to times through by 100, and that's going to give me 33929 point, and then you've got these extra bits going in as well. Okay, that's 100 tins, and that is centimeters cubed because I've stayed in centimeters cubed. Now, I want to know how many litres that's going to be. I can see that there are 1,000 centimeters cubed in 1 litre. So we are going to divide through by 1,000. So we're going to go 1, 2. It's going to put us at 33.929. It says to the nearest litre. So that's going to be 34 litres. I've just noticed a slight error. Can you see it? It says centimetres squared there, and that should say centimetres cubed. Okay, it will definitely say centimetres cubed on your paperwork. Okay, so 34 litres is the answer there. All right, your very, very last question. Hit pause and press play when you're ready. Okay, we're just factorizing here. So drop my X, it's pos neg, multiplying to make 24 is 3 and 8. I want to make positive 5, so 8 must go there and 3 must go there. So we finished off on hopefully a fairly straightforward one. It's massive what you've done. This course covers so much. I hope that you feel you have made a lot of progress in a lot of topics. You've got these videos available to you for a long, long time. So please make sure you reuse things, revisit things. You can do these consolidations to revise from again. There is a lot that you can continue to do to continue to improve and make progress. Just left to say congratulations, really. You know, it takes a lot to work the way through one of these courses. Really hope you have enjoyed learning with us. We've got lots and lots of courses. So if you are continuing your studies, please do take a look at what your next steps could be. And hopefully we will be there in that journey with you. Thank you again for studying with us, and hopefully work with you again in the future.